Silicon Valley CTOs are secretly moving away from React. As soon as I saw this headline, I knew I had to talk about it. There's a lot of info in here that's actually very interesting. It seems like a lot of CTOs of companies behind closed doors are discussing and planning their moves away from React. But there's much more subtlety to this story than this title seems to suggest. And a lot of the moves these companies are making seem really misinformed to me. I really want to dive deep on this and why some companies are rethinking their move to React, and also what they can do in order to fix the problems they are currently experiencing with React. They do have real problems. I will never say otherwise, but I don't know how many of those problems are React versus React enabling developers to do things that are less than ideal versus bad developers can get by with React and they're more likely to make bad decisions. There's a lot of layers to this chaos. Believe it or not, the React team isn't paying me to defend them like this, but someone has to cover the bills. So a quick word from today's sponsor, and then we'll dive right in. As you guys know by now, T3 chat has exploded, and people are asking me about it all the time. And there's one question they ask more than any other. Where's the mobile app? Well, I have a great answer finally, and the answer is actually today's sponsor, Infinite Red. These guys are who I picked to help us build the T3 Chat mobile app. We're about to get started, and I'm so excited to show it off once it's ready. So why did I pick this random firm instead of hiring a bunch of people? It's because they get what they're doing really, really well. I'm in great company with the other businesses that they've worked with. More importantly, I trust the team themselves. Jamin's an old friend. He was one of the first people to see my content and really get what I was doing. He was actually the first person to invite me as an individual onto their podcast to talk about tech stuff, which was super cool really early on. He's deep, locked in, and gets this stuff more than almost anyone else does. The rest of the team's been awesome to work with as well. These guys really get React Native, and they're not trying to hold that back from you and then sell it as a service. They're trying to help you level up too. If you want to use them to build your app from scratch, you can do that. If you want to bring them in to come fix your old broken app written in Kotlin or Swift or Java even, they can help with that too. And if you have an old React Native app that needs to be polished up and modernized, they can absolutely do that. But one of the coolest things they can do is a bootcamp. They can come in and onboard all your engineers to learn React Native, be it old mobile engineers, backend engineers, and obviously web engineers as well. They've had a ton of success with that. Realistically speaking, most companies don't need a React Native expert to make a great app, but they do need it to get started properly. Scaffolding React Native and getting all the parts proper is not an easy task, even for a dev like me, and I'm so thankful to have Infinite Red guiding us down the happy path to make it so our entire company can confidently ship on top of a great start. Thank you to Infinite Red for sponsoring today's episode. Check them out today at soydev.link/infinitered. This will be fun. I also want to say up front that we will not be reading this whole article because I had already started filming this before learning it was actually a member-only story. So if you want the whole article, the link's in the description, but you will have to pay the Medium subscription to read it. So I'll be intentionally skipping sections. I don't want to create an alternative piece of work from their article that you can use instead of reading the article. This isn't a market alternative. This is a response. And I will do my best to read this in good faith, not the whole thing as content. So if there are pieces missing and you're curious, the link's in the description. React isn't failing because it's bad. It's failing because it succeeded too well. Those words from a CTO at one of the Silicon Valley unicorn companies stuck with me. We're having drinks at a tech leadership meetup in Palo Alto, the kind where people speak more freely after the second round. Conversation had turned to front-end architecture, and I noticed a pattern in these closed-door conversations that wasn't reflected in public discourse. React is still dominating, but a lot of these companies behind the scenes are starting to explore alternatives. Here's the first quote I want to start going in on. The VP of Eng for a fintech company that processed over 2 billion in transactions explained that they went all in on React in 2017, but by 2021, they had a major app with over 200 devs, and the scaling problems became impossible to ignore. So, apparently, an application with 200 devs working on it with React will result in scaling problems that are impossible to ignore. I can't talk about all companies, but just to start why I don't necessarily agree, we had over 600 devs working on the Twitch site. And the scaling problems were not React. They were, funny enough, TypeScript. TypeScript's whole system was struggling under the weight of the size of that code base. React was totally fine. This is another really important point the same person made. The React ecosystem made a series of bets that haven't paid off for large-scale apps. The constant churn, the performance challenges at scale, the growing complexity of the mental model, they've created a perfect storm for teams building serious applications. Here is where I really start to disagree. The React ecosystem made a series of bets that haven't paid off for large-scale applications. Let's go through the recent bets that the React, rather than because the team has made. We have hooks, we have server components, we have concurrent mode, we have compiler. What other big bets has the React team made recently, like over the last 8 years? I think this covers the majority of the big ones. So if we have these bets, I will say wholeheartedly, hooks has been awesome for large scale applications. Do they allow for foot gunning? Yeah. Okay, people are saying functional components is one of the big bets. I would put that with hooks, though. Hooks have been awesome because of how much they standardize the way we add state to our components and also make that state reusable. It was very clear in the early React days that we needed a way to reuse stateful things across different components that wasn't just passing them around. For a while, we did just pass them around. That's why we ended up with things that were terrible like mixins, as well as things that were less bad like higher order components. So I wanted to give examples of how state worked in React before we had stuff as awesome as hooks. One of the first patterns we had were hawks, higher order components. These components would wrap a component in order to pass certain properties down. So if this counter needs access to the increment and decrement function as well as the current count, we could define that here with a with counter function that returns a wrapped component that then will take this consumer wrapper, grab the context, pass it as additional props down to the component, pass whatever was here down as well. It's a messy pattern, but it worked. Higher order components were how a lot of applications were forced to manage state when you wanted reusable state. Like if I wanted to write a GraphQL query that would render the component with that data when it completed, this is how we would do it a lot of the time. But there's an interesting piece here. Right here, this context bit. When we render counterComponent.consumer, this renders a child component and it passes it certain props. So we are taking that component, because components are just functions, taking its input, which is the current context from the counter context, which by the way is defined wholly separately up there, obnoxiously complex. And we pass this so we can render the correct component, which is coming from the with counter wrapper there, with the wrapped props. It's so annoying to manage this pattern, especially at scale, especially once you have weird props being passed around in the process. It's not fun. And then we had render props, which is actually part of what we saw there, where you have this consumer wrapper thing. It calls with these specific properties, and then you write the component here by passing those values down directly. Oh, the good old render props pattern. This was the worst. You ended up with tons of these giant callouts in the middle of your components, and you couldn't do any state management here either. You couldn't do much of anything unless you write a full function in there with value changes and a return. The problem here was the composability. It meant that to wrap anything or add state anywhere, you had to define these giant wrappers, these context layers, in these terrible patterns in line, when all we wanted was to get this state. So let's look at it with hooks. This is with context. So here we have, again, we're assuming that the context is where the state exists initially. And now we can just use context, counter context. And now the component, we have the state, and then we have the return. It's so much simpler. The magic here isn't, oh, look, the syntax is better. This scales better. This composes better. This lets simple things be simple. And something as simple as accessing data in your component was not so simple before. So here we have a get users query in GraphQL. Pretty simple. We want users by these fields. If we wanted to do this with a higher order component, we would wrap the component with this GraphQL helper from Apollo. We would pass it first, the get users query. This is now its own function we have called, and it returns a new function that we pass users. All of the type data we would want here, we have to define ourselves or add a build step where we can manually type it there. Because the data doesn't live in the component. The data is passed to the component through this wrapper layer. The order of events for how data goes to the right place here is terrible. It's really bad. And now we can just render our users with Hawk component, but we have to re-export things or export a default in order to do all of this. And it's a mess. I had to do this so much and it sucked. Render props is better but worse. It's a little more like what we do nowadays, but tabbed out a whole bunch and inline in weird ways. Users with render props, we have a query component. We pass it the get users query. This then calls its child component with loading, error, and data. And here we have the types now, which is cool because this now knows enough to know what the types are because it happened right there within the closure. The problem is we have to write all our logic there now, or we can put in another component, but now we've just made hawks more complex and we don't get the type safety benefits either. There is no ability for a component to access state and to know what the state is unless you wrap it. The component can't pull in state. The component has to be passed state through a wrapper. Let's look at the hook. Loading error data equals use query get users. If loading, we return loading. If error, we return error. Otherwise, we return this. How is this not comically better? I've seen a little bit of I miss class component sentiment recently, and those people just aren't building serious apps. This is just so much better. It's so much better. You get the idea. So I think we can say definitively hooks were better, at the very least more manageable. I would make the argument they are a huge win for large code bases because we no longer have to break up the reusability via components. We can make a hook and we can define a custom hook too. And that's the coolest part. We go back to the example here. We can, instead of use query get users, I can do the following. Export const use user data equals, there you go. And now I can have this use user data hook in a bunch of different places, and it's doing the same thing. The fact that the state can be reused this way is awesome. I love that, especially when the state gets more complex. Like you're using external state machines, or you're managing a shared entity for that state behind the scenes with like Redux or Zustand or something like that. It's awesome. The ability to define these bits of state as reusable, composable pieces where I can call multiple of them in the same component is such a massive win that I cannot sympathize with the pro class component people. This was so much better. It's such a huge win. This is also, I'm biased because I got into React around this time and it was such a good move. I'm so happy I did because this pattern has made architecture of applications and the composability of them significantly better. And it's also where we're going to start developing a theme. So if we're talking about hooks, before adding state was hard. Now, adding state is easy. What happens next? You guys are smart. What happens when you take a hard thing and you make it easier? Let's hear it, chat. There's one guarantee for what's about to happen. Look at that. People do it all the time. More adoption. People use it too much. My dad comes home. It's not the complexity goes elsewhere. That's not what happened here, actually. The complexity was gone, but that had its own problem. More people are going to start using it now. More state. Because adding state got way easier to do, where previously it required a relatively deep understanding of how React managed things. Like to understand render props, you have to deeply understand the way that a component is just a function, and the fact that the child can be called with custom parameters by the parent in this way. It's a weird niche way of using React and kind of abusing the child rendering system. And you have to understand it at least a little bit before you can add any state to your components in an even vaguely reusable way. That was a huge blocker. Most people couldn't add reusable state to their components because of this. That meant you only had a couple devs who could build these systems and everyone else would copy paste it. That meant that most React devs were way less productive, but also they couldn't do as many bad things because they couldn't do as much in general. If we were to say that theoretically, 30% of the decisions a average React dev makes are bad. So we say like, this is the bad part and this is the fine part. If they're only making this many decisions, it's not that big a deal, especially if a senior dev can come in and clean up whatever bad decisions they made. So if we were to theoretically make it less, that's great. But what if instead of changing the ratio here, we just, 10x'd the amount of these decisions being made by these less good devs? At that point, it wouldn't even matter if we made it 10%, because the number of decisions these devs have made is going up. Because previously, those devs were copy pasting code they didn't understand and couldn't do things that weren't already in the code base. Now, even if making the right decision is easier, they're making way more of them. There are more of these devs shipping more code. So even if they cut the percentage of bad decisions in half, it's going to feel way worse because there are more junior devs, more inexperienced people who don't understand React as well, writing more stateful code because they made it easier. Let's be real. When we went from horses to cars, the number of accidents in transport probably went up a ton. If we were to frame this as like last year, only 200 people died on the road. This year, over 400 people died on the road. Ban cars. Hopefully we would agree you are insane. Because like the problem with cars isn't that they're way more dangerous than horses. The problem with cars is that suddenly way more people are doing way more transport way more often. And if we were to measure this not as a raw number, but as a percentage of total miles traveled, you'd realize how safe cars are. That's also the case with flying. Flying might seem terrifying. When you look at the percentage of accidents and the percentage of fatalities relative to the miles flown, it's like 1,000th as dangerous as driving in a car. And yes, what I'm saying here is hooks are cars. Before hooks, it was too hard to add state. Now it's really easy, which means that we now have way more state. That doesn't mean hooks are bad. It doesn't mean hooks are anti-big code base, because big code bases have a lot of state in them. It means we have a different problem now, which is instead of state is hard, so only the senior devs can add it, the problem is now state is easy, so we should make sure devs are adding it correctly. That's not a failure of hooks. That is a win of hooks. But it will always be framed as a failure in hooks because people will look at bad code and say, see, you couldn't have done this without hooks. Well, yeah, that dev wouldn't have made the thing in the first place without hooks. That's just how it is. So that's the first point I wanted to yell about. Concurrent mode was next. Concurrent mode was a really interesting change for React.
So concurrent React can work on multiple tasks at a time and switch between them using cooperative multitasking according to their priority. Concurrent React can also do something else. It can partially render a tree without committing the result to the DOM. So for example, React can start rendering an update, and if it hits a component that hasn't finished loading, for instance, React can wait for it to complete before it continues. And it doesn't immediately have to show a fallback or a spinner or a placeholder or nothing, right? And also, concurrent React, crucially, it does not block the main thread. To give a little visualization of what I mean by this, let's compare it to how React works today. So today, React is synchronous, which means when you update a component, React is going to synchronously process that update. It's going to do all of the work to finish the update in a single, uninterrupted block on the main thread, right? So the problem, of course, is that if the user events also fire on the main thread. So if you're chugging along, rendering an update, and in the meantime the user tries to type into an input, in synchronous React, that input event can't be processed until after the currently executing render has completed, so like all the way past the blue, right? In concurrent React, however, React is going to pause the current render. It's going to switch to complete the user blocking task, and then it's going to resume afterwards on the original stuff.
This is a big deal, in particular for big apps. Before concurrent mode started to be a thing, you would end up with the sticky keys problem. This is going to be very slow when we type. The reason is because they intentionally made these components slow to render. So if I type something and it triggers an update, I cannot type more until the update has been completed. So if I start typing the word castle, I type very fast. So I'm done typing the word. It got the first two letters before it froze, and it misspelt it because the events came in the wrong order because the events were blocked by the render step. So if we switch this to be concurrent mode, where the render gets canceled and deferred because it's happening in a separate thread, so the input can be processed even when React is still rendering, it means I can just type freely and it's fine. I don't get the sticky keys anywhere near as bad anymore. That's a huge win, in particular for really large apps that have a lot of JavaScript and a lot of components. Concurrent mode didn't happen in the traditional concurrency like demo they gave there. It's a very different implementation internally now. But the vast majority of React apps could just bump versions, stop using the 3 or 4 deprecated things, and just have the win. And the results, incredible. Like, so many React apps got way faster as a result of concurrent mode. And wait till we get to compiler, because then it's going to get even better. But concurrent mode didn't happen in the traditional sense where like it's now a flag you can turn on and off. It's just improvements to the scheduler for React internally. But man, The results have been incredible and allowed for big apps to have much better, more fluid experiences, despite the fact they have a ton of rendering going on. You could make the argument that concurrent mode was primarily focused on helping these big apps perform better, and that they did that because of the performance issues they were having with React at Facebook due to the massive scale of how people were using React. Hooks we've established allow for much simpler composability of state. Sure, that means beginners can write worse code, but those beginners wouldn't have been able to write any of the code at all before. Not a real argument. It actually does help big code bases a ton. Concurrent mode, massive win for massive code bases and projects. Next, we have server components. We have a lot to say about these. So let's do a really quick TLDR on what a server component is. Server component is a component that runs exclusively on the server, which means the server can now send to the client something that isn't just data. Traditional React apps are built as a single page app, which means JavaScript runs, it checks what route you're on, and then renders the right components. Those components can then fetch data, making fetch calls using GraphQL to make them whatever else. So the components can get the data they need to then render the right UI. But all of the things the component can render have to be owned in the JavaScript bundle. So if we have a component that has 3 tabs in it, we have A, B, and C. A user can click any one of these and it will change the content of what's rendering to be A, B, or C. But let's say it needs to get some state from the server here. We have A started by default. So A is selected. Mark it green to show that. Now the body here needs to fetch whatever is necessary to render this part when that tab is selected. So this will then go to the server, fetch some JSON. The JSON comes down, and now the JavaScript code has to take the JSON in this format and turn it into HTML in this format. And the role of the JavaScript is both to call this data from the server and then turn it into the UI that you see in your application. When you fetch this isn't that big a deal. You could fetch it right when the page loads. You could fetch it way higher up. You could even pre-fetch for B and C ahead of time. So when you click them, the data is already there. The key is that the data has to be turned into the UI because the components are only fetching some JSON, and that JSON then becomes HTML because the React code in between turns the JSON into that HTML. What if instead of tabs, though, this would render something different depending on what the server decides? What if we on the server decide if this is going to be A or B or C? Now, even though we don't have tabs, we have to implement the code for A and B and C on the client and have the different states that the server can send, A or B or C, and hope that the server that's sending this and the client that's rendering it are in sync. So if I send down a B, the UI knows what to do with it. It knows, okay, we have to render the div with a B in it. But what happens if the component only knows A, B, and C, and we send down D, or we send down K, or we send down sub, please? Seriously, why are you guys not subbed? It costs nothing. Just hit the button. Half of you aren't subbed. Come on, guys. The point here being, if you send something down that your code doesn't know what to do, if you have like a component, function, tabs, and this component has const data equals use data, if data equals A, return div A. If data equals B, you get the idea. If this code has to exist in the bundle for every single different state the server could send us, now we need to make sure the client and the server are in sync at all times. And if there is a change that we want to render a new type of thing, we have to revalidate the client bundle. So they have to refresh and get the new JavaScript in order to render the new type. What if instead we could do this? And data, instead of being a JSON payload, data was the HTML we wanted to render instead. That's effectively what server components do. The reason for that is because of a thing a lot of companies have had to implement: server-driven UI. Server-driven UI, otherwise known as SDUI, is a very, very common pattern for big businesses. It's literally built for large companies that have these many client, many server, many things problems. Because if I have a news feed on YouTube or Facebook or whatever, and the feed has different types of components in it, we have, I don't know, a video player, Then we have a text post or like a community post on YouTube. But then we have, I don't know, let's say it's Valentine's Day. So we have a Val Day post. It's a different type of post. If the team building the feed decides they want this Valentine's Day post, it only works on Valentine's Day, then they get rid of it. And now they have to make sure way ahead of time that all the phone apps that render the feed, that all the TV apps that render the feed, that all the platforms that get this have a primitive for it. Otherwise, when they send from the server the array that is video player, text post, Val Day post, it's not going to know what to do with the ones you don't already have code in the client for. So you have this huge desynchronization problem now where the user has to be on the right version of the client before they hit the API. And if the client is ever out of date, it's possible that any API call could result in a broken render, a bad render, an error, or an outright failure of the app of some form. And when you realize that half of users of your mobile app are on an old version of the app, this gives you existential dread. You effectively can't add new user experiences to your app until you put them in the mobile app or put them in the website, get all clients up to date, then you can update your backend. But until then, you can't. And that sucks. It sucks really hard. So what does it have to do with server components? Remember the example I had here where I said instead of returning the data that we then turn into a component with a bunch of if statements, what if this was the HTML instead? That's server-driven UI. Instead of the client having JavaScript code that knows what video player is and renders the right thing, what if instead the server sent back what to render? So if the server sent back HTML effectively, or on mobile, the server is sending back like primitive React Native bindings that aren't like the actual native code or anything. It's sending back the instructions that effectively would have been what React Native did instead. You're now writing that return statement, that JSX, on the server instead. You've reduced the amount of logic on the client side significantly, and you've allowed yourself to change in one place on the server what type of data is being returned and what type of renderings are happening. And now you don't have to update the mobile app or the desktop app or the JavaScript bundle at all, and you can still render the new type of post because this doesn't need to know what a Valentine's Day post is in order to render it. You just hand it the JSX and it will put it on the screen. This is how every single large platform rendering different types of content has moved to doing it. If you talk with engineers working on the YouTube mobile app or the Facebook feed or Instagram or Snapchat or any of these businesses, they have built their own server-driven UI platform, primitive, and path in order to solve these problems. There is an issue though. Every single fucking company did this their own way. The barrier for entry for doing this type of thing was disgustingly high. Do you know how hard it is to write your own data primitive that can properly turn into an iOS element on iOS, an Android widget on Android, and the right HTML on the browser with JavaScript integration in it? It sucks super hard. It's really bad. Just like one fun example, I bring this one up a lot. Project Lightspeed was an attempt at fixing Messenger so they could change the way it worked and share logic between iOS and Android without having to rely on the app binary being updated. So what they did is they commanded the entire app with SQLite. Yes, the dynamic template layer that controls the UI for Messenger is done in SQLite. So if they want to change the UI for Messenger or add a new feature or do those types of things, they can ship a SQL migration to your phone, not care which version of the app you're on, and you're good to go. They're not making these bets for fun. They're not doing this because they want to force React down our throats. They're doing this because they have real problems that are solved when the server controls what experience the user gets, rather than the user's JavaScript controlling it instead. Server components are server-driven UI for everyone else. If you don't have hundreds of engineers that can build their own SDUI pattern, then you're a normal company. There are like 5 companies that have the right staff to do this, and even then they make mistakes with it. Server components are an attempt to take what Facebook learned by building their own patterns for this all over all of their apps and make it a standard so we can use it however the fuck we want to. This is an even bigger deal for mobile than it is for desktop and web, but it's a huge deal for all of them because it means, first off, way less client logic, which is huge if you're a big company. If you're building a feed that has lots of different types of things in it, like your feed has 500 types of posts, Instead of having to write the rendering logic for all of those, bundle them up in the JS, and ship that to the user, you can now keep them on the server and just send the markup that's completed at the end. So we have way less client logic. We have way less version drift because we don't have to care about the client version anywhere near as much anymore. We have way lighter client bundles, not just because we don't have to include all of that in the JavaScript, but because we don't have to include all of the dependencies of those things, and we don't have to put the work into rendering it on the client side. And the render on the server is cheap. So before people start saying, well, we're offloading the compute, running it on the server is expensive. No, it's not. It's not a real expense. Also, this is one of the craziest unintuitive ones. The data payloads are, on average, smaller. You would think that sending the markup would be bigger than sending the JSON. But the harsh reality is that most people are fetching way too much JSON. So if you send just the markup representation instead, you end up sending less data most of the time. So now I will pose y'all yet another question. Who benefits more from these? Your options are big companies, small companies, and early career devs. Of these three options, who benefits the most from a standard way to do server-driven UI so you get all of these benefits? Okay, course sellers is a really funny answer. Early career devs is also a funny answer. Is this really not that obvious, or are you all trolling me? Okay, thank you, chat. The biggest winner by far here is big companies, because small companies have way fewer of these conditions and way less complex feeds. So they don't benefit from the client bundle changes anywhere near as much, and their infrastructure costs are low enough that the smaller payloads barely even matter. Their bundle hasn't gotten to the point where they benefit greatly from the shrinkage. Why the fuck would an early career dev benefit? This is more to learn. They're just going to be angry about it. That's why I honestly think a lot of the pushback on server components has been because these parties don't benefit enough from it. The early career people in particular feel like it's way more stuff to learn. So these people just bitch endlessly about it. The real winner with server components is big companies. The reason this was built is because big companies have these problems, and either they survive or bias their way through it, taking a ton of hits along the way and build their own solution to the problem, or they fail. I don't see how you can point to this as bad for big companies. They're the ones who benefit. If you were a big company that was halfway through building your own server-driven UI implementation and server components happened, you should be praying to the gods at Meta for giving us this gift. It's great. People seem confused, like, why don't small companies benefit? Because they have smaller apps. It's really simple. This is for big apps. The benefit here is if you have a lot of code, you don't have to ship all of the code to the client. It's really simple. I'm begging you guys to understand this. I'm sorry, I'm frustrated about this. It's just obvious here that if you have a bundle that's really big and you want to cut it down to small pieces, there's a good chance you're a big company. This is a huge win for big businesses. And this is a huge win for big teams working on big apps. That's the whole point. Is it hard to move to a server component model when you didn't start with one? Yeah. But managing a code base with 500 people contributing to it, that's at the point where you're shipping hundreds of megabytes of JS across things that are actually written by you and your team? Obvious win. The only issue is sluggish navigation or many loading spinners at the app. No. You have to wait for the data load anyways. If you were doing this client side instead, you'd be waiting on just as many loading spinners. I like this framing. Actions are net benefit for everyone. Server components, though, are mostly beneficial to large companies. I'll be real. If you aren't already interested in the pattern of server-driven UI, server components might not be the right thing for you to be chewing on right now. Just because of all of the fear, uncertainty, and doubt being spread about them, if you don't see the immediate benefit for you, just stick it out. Chill a little bit for us to figure out how to explain them better. This is the pattern I think everyone should be using. I don't know if they should be just yet, but I would make the argument that right now, server components are only a mandatory move, only a thing you should be excitedly reaching for in this moment if you have problems that match these things. If you have a problem where the version drift on your client app is causing people to get the wrong state, get broken renders, hit error cases because the server changed and the client's out of date, server components will help you a ton. If you have way too much logic on the client side, or your bundles are getting way too big, server components will help you a ton. If shaving 15 to 20% off the data payloads you're sending via API calls would benefit you, or reducing the number of API calls and auth requests that are happening, server components will save your ass. But if a 20% decrease in cost on data processing is not attractive to you because the number would go from $10 to $8, stop talking shit on server components. You're not the one who benefits the most from it. And this is why I'm so frustrated. To go back to the article that started all this, which we've been away from for so long that it timed out, I am frustrated because they're claiming that these bets aren't beneficial to large-scale apps. I would argue that the majority of the bets that they are making right now only really benefit large-scale apps. Hooks benefit everybody, way better. Concurrent mode had the ability to benefit everybody, but primarily benefited large applications. Server components are the attempt to distill the learnings that Facebook and YouTube and these other companies had about how to drive UI from the server and make that reusable for devs of every size and companies of every size so that small companies can set themselves up for success, but more importantly, so big companies have a way out of the hell they're currently in, sending way too much JavaScript to the user. And now we have compiler. The React compiler, I would hope, and I'll ask chat again, who benefits the most from React compiler, guys? Who benefits the most from React compiler? We have junior devs. We have my 2 users. Big companies. Thank you, chat. Big companies are the biggest winner from compiler. They ran compiler on a bunch of code bases at Meta, including the Facebook code base and the Instagram code base parts that are in React. And despite the fact that it was Meta, which means it's the people who made React, and they are for the most part writing much better React code than a lot of other companies do, the compiler still saw massive wins.
This is an actual, real React component from our code base. I had to rename some of the variables for legal reasons, but please trust me, some poor engineer at Meta actually needed to write all of this to describe their UI.
If you didn't hear her, this is the code for one component.
And just to repeat, this is a single function, one component.
Small teams aren't writing this shit. This is a big company problem here.
We're not going to read any of this code, but I want to show you why it takes so many lines to describe this logic. Let's Control F to search for every call of use memo and use callback. Wow, that's almost 20 places where that developer hand-optimized an object. I also want to see how much of this code on the screen is spent just describing memoization. So let's also highlight the dependency array arguments. Oof. So all of the code in red that only exists just to describe how to avoid recomputing values. And finally, I want to see how much of the business logic had to be wrapped in past use memo. This reflects how much cognitive overhead it takes to edit the core logic of this component. Oof. So now that we've kind of drawn this graph and written these axes, I'm going to tell you about the real meta apps represented here. This highlighted point we've been talking about, with the super long piece of code, that comes from a React Native app called Quest Store, the app store for Meta's Quest VR devices. Meta engineers spent a really long time hand-optimizing Quest Store because of how dynamic and interactive it is. For example, take the product details page, which I'm showing here. I've already bought Beat Saber, so I get a button that says download instead of purchase. And I can click or scroll with my headset controller through the left panel for different detail types, which might also differ across games. Now, you might also recognize another very dynamic, highly interactive React app built at Meta, and that's Instagram.com, a pretty complex website with a lot of hand optimizations. In 2023, we began rolling out React Compiler on both of these apps. Now, I originally had some boring stuff here, like how we resolved to roll out without rewriting any code, and how the compiler avoids cheating by removing memoization that developers wrote. But let's just get to the fun part and talk about some results. The rollout was a success. React Compiler has been enabled on Quest Store and all of Instagram.com as the default experience. So if you've browsed for any Quest apps or used any part of Instagram.com in the past couple of months, you've almost definitely been using React Compiler. In terms of performance, we measured that for some click and scroll interactions, the compiler-optimized version was more than twice as fast as before. We also saw initial load and cross-page navigation times improve by up to 12%. And finally, we observed that there was no impact on either memory usage or overall crashes, which may reflect out-of-memory errors. This improvement didn't apply to just a few pages either. We observed that Quest store loads and navigations got faster by at least 4%, and Instagram saw an average 3% improvement across every route. At Meta, this was a really big deal. I mean, to put these numbers in context, engineers had combed through every single bit of these apps to add thousands of memoization calls. And of course, this work was done against metrics, which rewarded and the scale of every single optimization. On such an app, improving just a single thing, something like the time to first paint of a specific page, by just 1 or 2% would already be a huge deal. But React Compiler had significantly improved the performance of nearly every page it rolled out on.
But sure, React Compiler will make your to-do list app like 10 lines of code fewer and 15% faster. So clearly, Compiler is just for small apps and small devs, right? This is why I'm so frustrated, because all of the big arcs that the React team has taken on could be potentially pitched as for earlier career devs if you don't understand them at all. But the winners, the biggest winners for all of these developments are people who want to build businesses at the scale of Meta. The reason that they did these things is their own internal needs, learnings, and usage. All of these bets that the React team made were made to make it scale better for big apps. And most of them have already paid off, and the rest are quickly on the way there too. It's just insane to me to look at this list of things and be like, I don't know, but I don't like Next. React team evil. They don't get me anymore. This is how I see a large portion of the anti-React sentiment. It's this. So to go back to that blog post that I now feel I am fully in fair use territory for, let's go through the patterns that are driving the shift. Let's start with the performance ceiling. Performance ceiling effects. Some of the best performing apps ever made were in React, and some of the worst performing apps were made in vanilla native technologies. So let's see what they have to say here. We've got a team of incredible React developers who've optimized everything they possibly can. We've implemented virtualization, memoization, code splitting, server components, all of it, and we're still hitting fundamental limits that are baked into React's core design. They're a Series C productivity SaaS. Our React frontend hits performance bottlenecks at around 60% of the interaction complexity of our native app. Yeah, you're comparing a website running in the browser to a native application. Are you joking? Yeah, running something in the browser is going to inherently have more performance restrictions than running it in a native layer. The fact that React can get to 60% of the complexity of your native apps is insane. To think that this would be better if you used vanilla.js instead is delusion. Actual insanity. So let's go through these specific issues. There's rendering performance for large data-heavy dashboards. As we just established, server components help a shitload here. And more importantly, React Compiler carries so much here too. Performance for these types of things just got way better. Generally speaking, if there are large data-heavy things and they're running poorly in React, most of the problem comes from using React where you shouldn't. Like, you shouldn't be afraid to pull things out of React. There was a great tweet from Adam today that I feel like emphasizes an important lesson more people need to see. A staff engineer and I are working on sister projects that involve playing audio. We need to make sure one track stops whatever was already playing. I spent hours trying to add React context bullshit. He just did this. Document query selector all, audio, for each. If A is not the audio we care about, we pause it. It's great. More people should be willing to do this. If the problem you're solving is not best solved in React, don't fucking solve it in React. There's no shame in calling code that isn't React-y in your React code base if it makes the problem simpler and more performant. I would say in my React code bases, less than half of the code is React specific. Theoretically, I could move T3 chat over to another framework, and the hard part's going to be porting our component library or building a new one. All the data and state management stuff's already abstracted into a different layer. In our case, we're using Dexy right now. By the time this video goes live, we'll probably be using something else because we could swap it out. Leaning into Convex right now. Thank you to them for all the help with everything. But that layer is fully separate from the JavaScript React side, to the point where people are building user scripts to customize and change the experience on T3 chat because the Dexy database layer drives the UI. If you change something in the Dexy object, the UI updates accordingly. The React part is just a function that runs with state and outcomes UI. And if you treat it that way, it is very, very good and very, very performant. Memory usage patterns. If you're having memory issues in React, the problem is not React, the problem is the way you're using memory. I thought compiler would have a memory hit, but it's been discovered since people started implementing it that there is effectively no memory impact with the new memoization patterns because they hold off on so many other additional things as a result. So I would like to see what's causing memory problems. I think the bigger problem here has less to do with React, more to do with the fact that devs that don't know how to use the performance tools in Chrome can now build large apps. It is not React's fault that a dumb dev that doesn't understand the browser can build a giant app when before they couldn't. The problem there is that the devs don't know how to use the performance tools they have to find these problems. That has nothing to do with React at all. And I guarantee moving off React won't solve this memory problem as soon as you have an app of similar complexity. These people just don't know or necessarily even care about the problem. The issue is, like, if you're writing code without knowledge or care about performance, your code will not perform well. A framework swap won't change it. Next point's initial load performance, especially on mobile. And I agree. When you go to a big React single-page app for the first time on a mobile device with a bad internet connection, it's not great. You have to load a ton of JavaScript into the client, which isn't fun. Once you've loaded all that JavaScript, you have to initialize it and run it, also slow on these older devices. Then you have to go fetch additional data from the APIs, sometimes via waterfall, so multiple additional back and forths. And then you could finally render the UI. So if you have these performance issues, again, perf issues on mobile, those come from, as I was just saying, 1, fetching large JS payloads. 2, running those large payloads. 3, lots of back and forth to server API. These are the key things that cause performance issues on mobile in React. Do you know what helps with lowering the payload side and reducing the number of round trips between the client and the server? Say it with me, chat. Server components. It's almost like the React team is working on fixing these problems. Crazy. Yeah, I agree. If you're running way too much JavaScript on the client, you're going to have performance problems on low performance clients. So let's move that off the client rather than move off of React and re-implement half of it ourselves, but worse, in JavaScript. Oh God, don't get me started on the growing complexity of performance debugging. Learn how the browser tools work. Your problem isn't that it's harder to debug. Your problem is that you don't understand the tools. I will say that the performance and debugging tools for React Native were not good. They are getting a lot better. But mobile performance is a whole shit show in the first place. So yeah. If this was an argument about React Native being hard to make performant without knowing the niche things to debug performance issues, that's an okay argument. I would hear that one out more than a lot of the other things being said here. But yeah, this is just utter bullshit. Also, on the point of like React having 3x the investment here, do you think that investment's going to go up or down if you move off React? Take a wild fucking guess. Point 2, the growing meta work problem. In 2016, React felt lightweight. You could be productive quickly. Now to build a production-grade React app, your devs have to spend 60 to 70% of their time on React-specific patterns, configurations, and optimization techniques instead of solving our actual business problems. Let's take a look at recent PRs on T3 chat. Let's look at ones we actually merged. Text wrap toggle for code blocks. That's a feature. Let's see how much of this feature was us fighting React-specific stuff. If is macOS, we changed the key. Okay, this line could be argued as React-specific, though we had to pass the dependency. Okay, so there's one line in this PR that's React-specific. Here we are passing the is wrapped value down. You could argue either way. I'm going to argue against it being React-specific, so you have to get that there somehow anyways. Code body wrapper is wrapped, Boolean, passed down. We grab the tooltip. This implementation is React-y, but it's not React that we're fighting with here at all. Is wrapped, set is wrapped are things we pass down. Perhaps us passing is wrapped around like that could be argued as React-specific. I would still argue against it. We have our div with the updated copy button. We have our use state for is wrapped. We pass these things to the wrapper, and we pass the result here to the code body wrapper. That doesn't feel very React-specific to me. And this is the first example, and I would argue it's going to be one of the more React-specific ones. Quote reply might have a bit more. Rate limits for providers, that's entirely server-side, so nothing. Command for Mac shortcuts only, same thing you saw before, nothing to do with React. Patch paste limit bypass via edit, nothing to do with React. Add token limits to text uploads, nothing to do with React. Me fighting post hog for 2 days nothing to do with React at fucking all. That was just some terrible node code. I'm going to do a long video about that one. That one's all fucking solved. Errors also show skeletons. This was a fun bug somebody reported. Let's see how reacty this bug was. Oh, we just didn't include this additional state check. This is actually a thing that's way easier because of React rather than way harder. So where's all of that time being spent fighting React? I thought that I was supposed to be spending 70% of my time doing React stuff. I think it's like 10. And the amount of effort that React has saved us, the fact that we could build this app in the first place, is insane. And even more insane is that I was using a Svelte-based chat app somewhat recently, and it was one of the slowest and most unperformant apps I've ever used. It crashed my Chrome tab twice. So no, switching to a faster, more performant framework isn't some magic fucking win here. It's not a win at all because it's not real. So I fully reject this. The only reason you'd be spending this much time in the React-specific patterns is if you have engineers convincing you that React-specific bullshit is necessary. And I've dealt with that. I ranted about this a bunch in my It Sucks Being a Good Engineer video, because I've been on teams where they write this crazy document about how they're going to use all the React features to add a fucking button to a dashboard. And you should fire those people. It doesn't matter what framework you're using. That dev is still an asshole, and they're still going to hold your team back. It has nothing to do with React. And as Chad is catching on to here, hooks made me way more productive. I don't see how React was more lightweight for developer experience in 2016. It makes no sense at all. Make it simple, make it right, make it fast. Absolutely. The changes to React have made it way easier to do simply with hooks, way easier to do right with compiler and concurrent mode, and way easier to do fast with all of those plus server components too. And as this person said, you can still write 2016 React code. You can write a class component and put it in your modern React code base, even doing crazy server-side shit, and be totally fine. Dumb, lazy dev propaganda. Don't mix them up with lazy devs, though. Lazy devs like React. Absolutely. I'm a lazy as fuck dev. Being lazy is a virtue of good developers. Okay, let's go through this list of things that you have to know in React. Component lifecycles and hooks. I'd make the argument that the point of hooks is that we stop thinking about component lifecycles and instead think of data and state lifecycles. I'm going to change that to that. Complex state management strategies. Okay, how about React query? I'm going to change this so I'm just mapping all of these. So I'm going to change component lifecycles to data lifecycles. We're going to change complex state management strategies to React query. Probably all you need. If you need more than that, then you have a really complex problem. It should be hard to solve. But if React query can be all that you need, you added that complexity yourself, motherfucker. If you're making something more complex than React query, either you need it, so stop bitching, or you didn't need it, so stop bitching. Memoization and re-render optimization. I thought we didn't like the direction of React, though. Guess not, because compiler makes this go away. Data fetching patterns. Okay, those are hard, but those were always hard. And we're making real improvements on it. Wait, data fetching patterns and server components are separate? Well, that was the whole point. Data fetching patterns, React query plus a bit of refetching. I'll go a bit further with that one. Just watch a fucking Theo video. They're like 1 or 2 videos of mine, and you will be more than good with data fetching patterns and understand it. Go watch my All the Ways HTML Gets to Your Browser video if you actually don't understand how that stuff works. This is one of my best videos, and it's massively underappreciated for what it is. Like, all the comments are, holy shit, this is so good. Why is nobody seeing this? This video will be more than enough for a lot of these things. That said, this is the first one I will say, yeah, it's somewhat complex. Not because of React, because data fetching in large applications is an inherently complex task. But sure, data fetching is something people need to know about. Now, server components versus client components. And I'll say the controversial thing here. Let me just move these so there's better spacing. Just skip until you need it. I think server components are awesome. I think more and more people should be using them. I am very excited for the future where more and more of us can use them for more and more things. But for now, whatever. If you actually think this is some big complex thing you have to learn, either you have really complex problems and you should do it because the alternative sucks. You have to build it yourself instead. Or spend a week-ish, not even, probably like 2 to 3 days, better understanding the idea that this component runs on the server, but it can mount a component that runs on the client. And just forbade any dev that isn't one of the 2 or 3 that gets it from writing a server component ever. Just force them to have use client on top of all their files and move on with your life. Not that big a deal. Suspense and error boundaries. This takes 30 seconds. Why is that here? Suspense means if there's a component that is blocking render because it needs something like data, the suspense boundary gets hit and it renders a fallback until the data is there. Cool. You now understand suspense. Error boundaries. If a component can error, you can wrap it in a thing called an error boundary. So when it errors, that component gets hit instead of crashing your application. Wow. So complex. That's so much you have to learn. Build tools and config. Just use Next, man. You can't complain about Next.js and then complain about build tooling and config. Pick one battle, motherfucker. Seriously, what? It's like, Python is hard because you have to learn about if statements, else statements, for loops, data management, threads, significant white space, pip, UV, V and V, variables, dictionaries. Python is so complex, guys. Why would anyone use this? You should just make your own programming language instead, or just write it in C++. Do you understand how stupid this is? If you just list a bunch of features, say, look at everything you have to learn. Ugh. Yeah, I hate doing the dumb voice, but this is a dumb post. Oh boy, the talent and onboarding crisis. This will be a fun one. I can tell this one won't drive me fucking insane. I am sure that there are lots of talented devs you can easily hire and onboard to your custom vanilla JS-based framework. I'm sure that's going to go great for you, motherfucker. Let's see what you have to say here. Several CTOs mentioned a surprise problem. While React devs are plentiful, truly skilled ones who understand deeper patterns are increasingly rare and expensive. What do you think there are more of? People who understand React's performance characteristics, or people who are available for hire that deeply understand how to build it themselves? And what level of knowledge do you think you have to know React well versus to build your own React? Cool. Let's take this quote. We can find 100 devs who can write React components, but finding people who deeply understand React's mental model and architecture for large applications, that talent pool is shockingly small. Do you think that pool gets bigger if you move off of React? Are you fucking stupid? I'm sorry, I don't mean to be this harsh. The way the article opened, I actually thought we'd have some good conversation here, but this is just the stupidest fucking thing I've read in a minute. Holy hell. Am I insane? You don't solve this problem by moving off React. If your application is large and has performance issues, changing frameworks doesn't make it easier to find people who can do it. This is insanity. I see why they paywalled this post. It fucking sucks. Again, if you want the whole article, make sure you go pay and read it on the website. I'm not here to give you a free alternative to the article. I'm here to explain why the things I'm reading from it are bad. If you want to digest it yourself without my interpretation, feel free. Go nuts. The link's in the description. But I just grabbed this quote from it. I wish they said what company this was. The quote is, in 2018, we could onboard a new engineer to our React codebase in about 2 weeks. By 2022, it took new hires 2 to 3 months to become truly productive in the same application. The learning curve has become exponentially steeper. Okay, let's pitch this one to y'all. If you have a code base that was easy in 2018 and is hard in 2022, which of these options is more likely the reason that happened? 1, React got harder. 2, the app got more complex. Or 3, there is no 3. Do you think a code base that was easy in 2018 and is now hard in 2022, that happened because React got harder, the app got more complex, or we moved to Next.js? Chat's already going. Got a lot of 2s. 3, he could have gotten dumber. Yeah. This crazy thing happens as code bases get larger. They get harder to work in. Crazy, I know. Absurd. Wild assertion on my part to say that an application got harder to work in because it got bigger and more complex. The lack of accountability here is just so absurd to me. Like what this is a bunch of CTOs that miss how easy things were when their code bases were small, and instead of finding ways to make the process better, they're going to blame the framework instead. It's insanity. Sounds with all my personal projects too. The first 80% of the app is finished in a matter of days. Getting it production ready is a whole other ballgame. Yep. I drew this diagram in my Future of HTMX video because the assertion was that React resulted in apps being too hard to maintain. But the reality is that over time, new tools and technologies made it easier to build complex apps. Before, this graph is how complex can your app be and time. The difficulty to build complex app is red. So it used to be really difficult to build a complex app, but over time it's gotten easier because of tools like Angular and React and hooks. Building complex apps on the web is easier than it's ever been. The complexity of the average app has gone up accordingly. When it becomes easier to make complex things, more people do it, and complexity goes up. The other important detail here is the expectations of users have increased too. Users expect better apps that can do more things, especially in the web. Previously, we expected a crappy application to check our email through adelphia.net that took minutes to load. Now we expect something as snappy as Gmail on our phone. These code bases being hard to work in isn't because React is so complex. It's because the product is getting more complex. And we should be thanking React for making it possible, not mad at React for being involved in the things that are now complex. The next section is framework churn. And this section is focused on all of the things that we have changed with how we manage things in our React applications. So let's see when these changes happened. I'll break these down one at a time. Class components to function components was pre-2017 to 2018 plus. So this one was 6 years ago. Shut up. And the best part, not only did we not deprecate class components, not only can you still use them totally fine, you can use them inside of function components and vice versa. I know, crazy, but you can write a function component and call it from a class component, and you can take your old class components and call them from function components. This is a huge net win that isn't churn because it's fully interoperable. This isn't Angular 1 to 2. Like, what? This is a better way to do things that we can start implementing and use alongside the old way. To call that churn is to not have ever experienced churn. You never had to deal with the thing you were using deprecating the way you used it and being stuck on an old version or like having to migrate off it. It sucks. If you didn't have to migrate an Angular JS 1 code base to Angular 2, don't use the word churn. You don't fucking understand it. Next point, Redux context API to signals. The timeline for this one's a bit weirder, admittedly. Redux, I would say, maintained its relevance until like 2019. Context was a weird era. I think we largely agree the context API isn't the way to manage your whole application state anymore, but it was an attempt to do better state management inside of React. So from 2019 to I'm sorry to we have good options now. Also, did you notice the lack of mention of React query? It's almost like they're ignoring this library that is used in a 4th plus React application. I think it's actually 6 out of 10 last time I saw. We're ignoring this library that's used by the majority now of React apps that reduces all of the churn here. And I've been using React query since 2018, and it's been my main state management choice since 2018. There's no goddamn churn there at all. I am more committed than ever to React query. And what's even crazier is hooks enabled that. Hooks enabled a primitive that's so good that I don't have to worry about all of this churn. Like, I play with Zustand and Jodi here and there. We use them a bit here and there in our apps. What's really crazy, let's look at the complexity here. Give an example of managing a semi-complex stateful object in React. Give the example using Redux pre-2018, context with hooks, and a more modern Zustand implementation. So here's how we would do this before with Redux. We would create all of our actions. We would create the functions to use for these. We would produce our reducer function that handles all the different cases and applies the right thing, but depending on the event. We would export a root reducer through a store. We would then consume that in the components by writing our handle add function that is part of a class component. So I have to call this.props.add item, and we have to get it that mapping by wrapping it with the connect to attach the state from Redux to the component. That is a lot of code. React context and hooks, quite a bit the same. We create the state context, we create the dispatch context, we create the reducer function again. We have the layers here. We have our use cart hook that handles these things, but at least the client code is now a decent bit less annoying. We just wrap with the cart provider, and now, as long as this is wrapping our app, we're good to go. We then use cart, items, add item, remove item, and we can just call those, and it's all fine. Awesome, great, cool. Let's look at the Zustand implementation. Import create from Zustand. Here's the whole implementation. Here's how we use them. We cut the amount of code in 2/3. And even better, the old Zustand code still works. It's still in our code base. It can still run totally fine. Twitch still has a ton of Redux everywhere. You don't have to throw away the Redux if you want to start using Zustand for new things. And I see why you'd want to use it. It's way nicer. On top of that, for a lot of these things, like in this example, items probably isn't coming from the client side. Items is probably coming from the server. So you'd probably want to use React query for this instead. Like items would probably come from server. Can you give an example with React query instead. So this is adding the fetch cart function, as well as custom functions for adding and removing, where we're hitting a real API. So this is already doing more than the code we just saw. Here's the Redux code now handling this. Oh. No, it's not. It's adding React query to all of those. That's annoying. Retry. Lol, Axios. Okay, it added a bunch of optimistic updates. Annoying, but fine. But how cool is it that we can take the API call, just wrap it in a function, and then call that with use query. Cart items, fetch cart. Use mutation, add item API. This whole part is optional. It's nice to do the optimistic mutation, so when you make the change, it appears immediately on the UI, but it's optional. And it allows us to not have to do any state management outside of the API management. Because the thing that these examples don't show is when you make a change to the cart, that has to be synchronized with the server. And when you load the page, we have to get the initial cart state from the server. This code goes from complex to obnoxious when that happens. We have made massive improvements. And I don't understand how you can frame improvements as churn, because they're all optional. They are comically better. They all compose with each other. You can add Jodi to one component in your code base without having to change the Redux code at all. Speaking of things getting way easier and you have to change the code at all, they got the order here wrong. We started with hawks and moved to render props. So I'm going to fix that for them. We went from hawks to render props to custom hooks. We went from bad but necessary to slightly better to way better. Also, that churn, 2016, 2016, 2018. So, no, we've had hooks stable since 2018. It's been 8 years since this churn happened. Okay, this one's just delusional. Migrating from create React app to next to remix to Vite? Are you trolling me? Am I falling for a troll article right now? I feel like I'm just being made fun of at this point. No one's actually done this. Absurdity. Okay, chat's concluded I'm falling for rage bait right now. Rage bait doesn't even make sense. Remix to Vite makes sense because it became a Vite plugin. Yeah. I need to migrate from Python to Go to Java. No, you need to migrate from Python to UV to Lisp. It's hopping between like technologies. Like Create React App is a template. Next.js is a framework. Remix is at the time. It's funny enough. It started as a template, became a framework. Vite's a bundler. Etc. What's etc. here? How do you etc. on your framework? What? And what's even crazier is like the migration from Create React App to Next is only complex if your Create React usage is complex. If you ejected from Create React App and added a bunch of crazy things to your Webpack config, you have a complex app. Moving to Next means you're making it less complex. The only reason this migration would be hard is because you are not using Create React App for what it is. You're adding your own things to it. And there's a good chance you get to throw those all away by moving to Next. That's huge. That's a big win. I did a Webpack 2 to 3 migration for Twitch before I learned React, and it was hell. I love doing that type of thing, though. Twitch's life would be so much better if they were on Next.js at the time. Now with TurboPack finally really happening, it makes more sense than ever to make that move. But yes, a complex app was not well served with Create React App, so complex apps that used it had to build a lot of things on top. That's why they deprecated it. Of this list, the only thing in here that's been deprecated is Create React App. And they did it because it forced you to implement that complexity yourself. Next handles it fine. Remix handles it fine. Vite can handle it fine. Create React App and its hell of Webpack plugins could not. We should be thankful that that died. And we should also be thankful that moving to Next isn't that hard. And the craziest thing is you can copy paste all your React components over and they work. The only reason moving from Create React App to Next would be hard is because you are doing crazy complex things in Create React App. A vanilla CRA to Next is an easy move. I've done it for many of the companies I advise and that I've invested in because they started with Create React App for some reason, and I port them to Next in literally 2 hours with AI. It's not that hard. Thank you, chat, for giving me my credit where it's due. I'm the reaper of Create React App. I put so much work into killing that fucking starter template. It was so bad. The Webpack word should be banned. You guys get it. Okay. So this whole line is just bullshit. I'm deleting it. Client-side rendering to server-side rendering to server components. So you have to do this, moved to, you might want to do this, to, this solves real problems for big apps. Okay, so you have to CSR things almost always if you're building interactive things. Fine, whatever, cool. You didn't migrate from client-side rendering to server-side rendering. You chose to add server-side rendering as part of the pipeline. This isn't a migration. This isn't a churn. We're not churning from CSR to SSR. We are adding SSR to our application. Using SSR isn't turning off client-side rendering. It is an additional thing to optimize the things we're sending to our users. And server components are an additional optimization there. These aren't things you replace one with the other on. These are things you add as you go down the line. Insanity. So yeah, that whole section of the churn tax is just bullshit. Half the time people talk about churn and like everything changing. I look at their argument and I laugh at it because it's just so fucking wrong. Credit where it's due. Traversy Media recently went on a rant about how bad a bunch of updates to React and Tailwind were. And he came back and apologized for it. A few weeks ago, I made a post bitching about framework updates. I mentioned React Router and Tailwind. I've been busy with other projects the past couple of months, so I didn't actually get to use them. I think I did what a lot of us do, and I saw some breaking changes and I got upset. However, when working with both Tailwind 4 and React Router 7, I've changed my mind. Both updates make them easier to work with. I don't like trash talking people that don't deserve it. I wish you were the one who wrote this article because it would have been deleted before I got to it. I have so much respect for Brad for doing this that I filmed a video about his original post, and I'm 50-50 on if I'm even going to bother posting it now. I did film an addendum about this because it's such a bro move, and I have so much respect for him for posting this. Credit to you, Brad. Thank you for letting us go through this with you. It is better than if you never made the post in the first place. I'm sad that this didn't get the attention it deserves relative to the original post, but it was important. And as he at the bottom, he doesn't feel like anyone cares, but he wanted to clear it up. I care a lot. It's so important. Thank you for sharing this because it makes the point that I hope the author of this article realizes. Also, he said that he did the same when hooks replaced classes. Now I couldn't imagine using React classes anymore. So my point is, go beyond the initial frustration. You may see that things are better for you in the future. Crazy. And similar to the React Router and Tailwind changes, they didn't really do breaking changes. You can move over to the new pattern, or you cannot. I'm using React Router 7 in my T3 chat code base as though it was React Router 4. Everyone saw React Router 7. They're like, oh my God, my application has to use all these new things. No, it doesn't. Here's our router. Routes. Route path equals whatever. Element, this one just navigates you to /chat, /latest chat helper, /new, /chat. All of these are components that have a route that renders a different component. That's it. This is how React Router has worked since I first started using it in 2017. So complaining about the React Router 7 changes makes no sense to me because this is React Router 7 and I could have copy pasted this code base from a 2017 code base and it works exactly the same. So like stop using churn when you don't mean churn. The reason that you're upset about server-side rendering isn't because it's more complexity. It's because you shouldn't have been client-side rendering. You feel bad, you see the solution, and you're angry it didn't exist when you started. That's not churn. That's frustration about investing too early in a thing. And do you know how you solve that? I'll give you a hint. Stop using shit so early. If you don't like when things improve, don't use them until they're done improving. Maybe check out jQuery or Angular. I know Angular is actually improving again, so don't check out Angular. You're not going to like the churn there. But go stick with jQuery. And fun thing, the guy who made jQuery is a big React guy now. He just built an awesome stack where he built a public open source app on Cloudflare using all the cool new React, Vite, and server component shit. It's actually really cool. So if you want to not deal with things improving, go to jQuery. But if you like when things improve, follow the guy who made jQuery over to React with us. This is pretty nice. And if you do want to benefit from these things, the process isn't that bad. Barrel of Lube, great username here. Just drop this. And this is actually very good advice. Step 1, delete package JSON. Step 2, get the default one from an npm init or like a Next.js init or whatever you're moving to. Run bun dev, see whatever errors you get, start installing shit until they stop. Also, you're going to have to go through and make some changes to handle like weird compilation errors because you had a weird thing in your TS config or you have some crazy Webpack config thing. But this strat works great. Make a fresh code base, copy paste all the source code over, and then fix things until it works. I've done this so many times. And no, Redwood isn't the jQuery guy. Redwood is the GitHub guy. Well, that's separate. The jQuery guy did a bunch of posts about the weird, I think it's like a wood carving tracking app that he built because he's really into wood stuff. And he built it with React in a modern stack and broke down how he did it. And it was really cool. The mistake that these devs made isn't that they used React, is that they picked a thing that's improving in the ways they needed it to improve, and they're upset that that happened. And I regularly say this. It is often better to get into a thing late than early. If you got into React when context was the recommended way to do all your state, I am genuinely sorry. That was a weird tangent we went in as a community. That was the wrong way. That's the only thing here I would really consider churn. Everything else here is improvements that you can use alongside the original version. So if the mistake was that you used React too early in 2016 or 17, and now you feel bad about it, do you know what isn't a solution? Using something newer. That will not fix your problems. If you're like, React is changing too much, so I'm going to move to Svelte. Do you know how you would feel right now with all the changes happening to Svelte? There is one really good point from chat just now. I should have considered this before. A lot of startups suffer from the phobia of not using the freshest or newest tech. I absolutely agree. This is 100% a thing that a lot of these companies and a lot of these tech leads are falling for. They feel like they have to use the new thing or they are failures. And that is a terrible mindset, and we should go out of our way to discourage it. This crazy app I've been building, T3 Chat, its state is primarily managed through Dexy right now. If you're not familiar with Dexy, I'm going to show you guys the website for it. Does this look like a really new library? Dexy was built in the IE8 era. The library that I moved to power most of the state in my React application, my huge React application that's doing more revenue than most of the businesses who are bitching right now. The license is 12 years ago. The library I'm using for managing the state in my brand new application that I started working on at the start of this year, the first commit for Dexy, February 2014. That's insane. This library is not new. I didn't pick it because I wanted the freshest, coolest, newest thing. I picked it because it solved the problem that I specifically had. You don't have to pick the newest thing. Pick the thing that solves your problem. I am not using any of the state management libraries that were in the post. I'm not using any of these. Okay, I'm using a little bit of Jodi, but barely. We're gutting the little bit of Jodi that we're using right now. Everything's Dexy based. Like, I'm using a library that comes before everything on this fucking page did. I don't get it. I really genuinely don't. Using something newer doesn't fix the issue of things changing. If you want something stable, use something older. What's cool about React is you can use it with React. I can use Dexy in my modernized React code base. I can move my routing to a library from 8 years ago or more because it makes sense for my problem. It's just like, there's so much over-engineering, and I can admit React enables over-engineering, but it enables it because it's flexible. It also enables under-engineering to a beautiful way, like a genuinely incredible way. A thing I built recently, it's a service for people to page me when a new model drops, so we can get it added to T3 Chat as quickly as possible. This code base is adorably simple. It might not look it from here, but it actually is. We have the auth token check, gets cookies. If there is no token, we throw an error. Then I grab data from KV to make sure that you are a real user. And if not, I throw. Otherwise, I return the data from KV. Then I have the models, which I grab from KV. I then I render the page. I render the form to page me with. And then I render all the models. But here is the part that matters. I do a data check where I use my try-catch wrapper to call the auth token check. Either I get back data or I don't. If I don't get back data, I render the auth form. If I do get back data, I render the model page. I then add a suspense so the page can load immediately. So complex. Terribly complex. How do I ever survive with this level of complexity in my code bases? Let's go to the page Theo form. I'm sure this is really complex, right? Well, I'm writing that action in a different file because I want to have client-side stuff here like toasts and whatnot. So I pass it an action that I wrote here, which calls the submit new model action with the data that they sent and the user's username. And then I revalidate on a fake path. This is a hack. This is the closest thing to a weird thing that I just happen to know because I use Next.js a lot. If you were to do this right, which is / for the page they're on, it's totally fine. By revalidating the wrong path, it will only change things that changed and not invalidate any caching values that exist before. It's just a weird hack. Doesn't matter. you should just revalidate on slash most of the time. Then here I have really complex code. Is loading, set is loading. Toast, use toast. Then my form with use form. My async function on submit, we set loading to true. I call the action. I toast when it's done. I reset the form. Or I catch the error and toast the error. And then finally, I set is loading to false. So complex. This is such a terribly hard to work in code base. How would I ever do this? React clearly doesn't scale with these new patterns. Do you know what does scale? I say this a lot. Simplicity scales. That doesn't mean if something is simple, it can stay simple at any scale. It means you should always be striving for simplicity at whatever scale you're at, because a large code base using simple pieces is going to be much easier to work in than a large code base using large, complex pieces. The larger your code base gets, the more you should strive for these simple things, because otherwise you're just compounding the complexity. If you have a focus point that the whole team is bought in on, which is keep things simple, you're not going to prevent your code base from getting complex, but you're going to meaningfully reduce the speed you get there. And that is huge. The simpler you can keep your patterns, the simpler you can keep your architecture, the easier things get. And just because your code base is gigantic and complex doesn't mean you have to have that complexity in every single feature. Give a button an on click when a button should have an on click. Have a simple inline use state where you should have a simple inline use state. Grab things from React Query where you can grab them from React Query. Eventually, you'll have some features that require complexity. Like the way that we manage the chat streaming in and updating the UI for T3 chat is inherently complex. So we built it in a complex way with the goal of making it as simple as possible. Whenever I find a workaround to make it simpler, I take it because we want to keep things simple. This is basic discipline in engineering. And if you don't have that, your code base is going to get big and ugly no matter what fucking framework you pick. Okay, we're down to the last reason, the dependency security nightmare. The average React application we audit has between 1,500 and 2,000 NPM dependencies. The security and maintenance burden has become untenable. Thank you, chat, for beating me to it. Ah, got it. NPM package security is only a React thing now. Crazy how only React apps have this. I bet if we switch off React, we would need way fewer dependencies, right? Right? I feel like I'm going insane. I genuinely feel like I'm going mad. Yeah, Solid is so much better because you don't need dependencies. You want the real hot take? You'll have less dependencies if you move to Svelte because there aren't any. Yeah, more packages than lines of code. It really feels like people are building that way. And like, it is what it is. That's their problem, not mine. The reality of this one is, in some regards, we have allowed devs to go a bit too far with NPM installing a 30-line of code thing. I think we should do better about this. We should put more effort into encouraging devs to not NPM install 500 solutions, but copy-paste ones that make sense for their code base. Like shadcn. Shadcn isn't a package. You can't NPM install shadcn. Shadcn has recommended minimal things that it uses for some of its components. I was going to say like badge, but it's not. Badge is just Tailwind and class variance authority, and class names. And class names is a util. It's not even a package. Okay, breadcrumbs. These use slots for Radix. Awesome. Have you read the Radix code base? It's beautiful. Really simple. Doesn't have a whole bunch of external dependencies. How about, I don't know, Sonar? Sonar is a type of toast. It's a really nice type of toast. Let's see what this is depending on. Oh, next theme, so it knows to do light mode or dark mode, and Sonar from Sonar. Wow, that's really complex. That's so many things. Yeah. The only issue here, and I will admit that this looks not great. So I hop into my package.json here. We have this section up here that's all the Radix dependencies, but they are changing this. So you just import one Radix UI package, and then it tree shakes depending on what you do and don't use. So that's going away. The other fun thing is that a lot of these packages are like server-side build tools and like types. Make it less likely that we make a mistake. Is it annoying to have to audit each and every one of these? Sure. So don't. If it's simple, copy-paste the code into your code base. If it's not simple, great. You just found a way to not have to maintain something that isn't simple. And that's the reality with dependencies, is either the thing is simple, so copy and paste it so you don't have to worry about security breaches or whatever the fuck you're concerned about, or the thing is complex and you should be thankful you don't have to maintain it. Those are the only two options with dependencies. I just don't get this argument. I agree that bad devs install way more depths, but that's not a React problem. The fact that React is a good enough framework to allow for not as good of devs to ship good applications doesn't mean you need to replace React. It means you need to replace those devs or give them better mentorship or force them to watch my channel. Crazy, I know, but like education is the problem here, and not like educating them on React because it's hard and special, educating them on basic development best practices because they should know them. The article had one more section on what people are moving to. If you want to read that, again, links in the description, but I'm going to focus on one of the 5 things here, which is island architecture. The example they gave here was companies moving to an island architecture, which is something like Astro, where you have an HTML page and then you can mount frameworky components in individual parts of your UI. So a given element can be with a specific framework. So if we want to reduce churn between frameworks, we want to improve performance, make the client side lighter, and not have as many dependencies, does giving their own dependency chain to every single element that's interactive on your page solve any of these problems? No, it makes them worse. Believe it or not, a company like TikTok, which is using a ton of micro front-end stuff and a lot of different UI libraries, they don't use React where it doesn't make sense to, they use React a lot of places too. Their dependency graph is thousands upon thousands of packages per load. It's crazy. Splitting up your architecture this way and breaking it into islands only reduces the number of packages in your hot path if you also made your application simpler in the process. And as your new island architecture app gets to the same level of complexity that you had in your React app before, you will have more dependencies, not less. It's just delusional. Okay, one last thing I have to riff on. We created an internal UI framework that's specifically optimized for our use cases. It's about 20% the size of React with vastly better performance characteristics for what we need. This is so funny to me for so many reasons. Principal engineer at a streaming company is particularly hilarious because there's only like 3 of them. So either it's Twitch or it's an incompetent company. Not saying that Twitch is competent. But what's much funnier here is they're measuring the size of React as a big win. How big do you think React is? Oh man, you reduced the bundle size from 130 kilobytes down to 20. And that's just the framework. Like the code base is not dictated by the size of this. Like these numbers don't matter in a real app. If we again go to like T3 chat and I go to the network tab and we look at the JavaScript being loaded, we're loading a lot of JS. I'll Command Shift R, so we have to hard reload all of it. 3.6 to 4 megabytes of JS. Cool. You reduced 1/40th of that by 80%. Proud of you. That's awesome. Seriously, if you're measuring the size of the React bundle as your win, you don't have anything to share or say. It's just not a big win at all. So like, I'm sorry, I'm frustrated, but if the thing you're bragging about is that you reduce the size of the thing that is 130 kilobytes to 20 kilobytes, as though that'll somehow magically make your app faster, you're fucking delusional. It's just insane. And if your application's code is even less than the 130 kilobytes, so that number actually mattered, you probably shouldn't have been writing JavaScript at all. It's just insane to me. I feel bad being this harsh. I didn't go into this expecting to be. I just thought that there would be better reasons to be moving off React and maybe some that had actual information. It's insane. I've never been so confident after reading a thing that everybody involved in the piece should have actually been using React. Like every person quoted in that is either too underqualified to make the decision to move off React or is trying to get more job security by moving off React. It's the only way you could say most of the things that were said in that. I feel like I'm going fucking mad. So I'm going to end this one now. Let me know what you guys think. And until next time, please don't move off React. Seriously, like this is just actually madness. Like if you don't have a good reason to be doing it or you have performance issues, just like figure that out. It's not that hard. I'm going to go insane. I'm going away now.